Good morning.
Good morning, sir.
Yeah. So thank you for joining a special session actually. And I'll share my slide. Are you able to see my PPT?
Yes, sir.
Yeah. Today first we will try to look for discussion on design cycle aspects. I think in the last class I was just giving introduction towards that. Some of you still have not joined. I believe they are joining us in data period, right? Yes, we can start, right?
Yes, sir.
Yeah. To understand overall, we were just mentioning that in this process of recognition, we will be going to use some data, right? That may be sometime divided as training data set and testing data set, right? So there are two phases of approaches with the system here. One is training phase and testing phase. So during the training phase, you'll be trying to make use of this data, and during testing phase, you'll be trying to use the rest of the data. So any clarification with respect to that? What is this process? So testing is a phase where you'll be trying to understand how good the system or classifier designed is, right? Even sometime we may consider along with that validation set for fine-tuning the training model, right? So this is the basic data set used when you think about a recognition system. A pattern recognition system may be trained initially and then may be tested generally for the performance, right, for which it is trained. So the overall design cycle we were just talking in the last class. So the first task may be of collection of data, and the second may be the feature extraction. So I think all of you know at this stage what is the feature is, right? It is some unique characteristic or some measurement, right, for a given pattern. So even that stage might have feature selection procedure, right, to be incorporated to choose the best feature. Because if you simply put some feature list for modeling the particular classifier, the computation will so on increase with the higher number of features. So when you are able to reduce the number of features, the computation reduces. So in that intention, dimensionality reduction we say. Could be achieved with the feature extraction procedure or feature engineering. This this may be trying to provide you better visualization of the pattern. In a way, it will help you to do with less computation, right? So it is a very important stage of our recognition system design approach. In that, the stage is very important stage. Okay. However, the next stage is selection of the model, and then you may have to train it. Once you train with the training data set, then you can go for testing, and then maybe the evaluation, say. So this you can call as testing and evaluation. So this is not only one way, right? Like this, you may have to do it many times, sometime. That we call as design cycle finally, right? It's not that it is with some simple choose of model such as say maybe one of the machine learning model, maybe KNN or anything. If you have chosen one of the model and if you have implemented certain task of classification, it may not give you good result sometime. The performance may be 70% or something which you observe at the end of the testing. You may not happy with this, whatever you get. So if you're not happy, you may have to go back and do modification of your feature vector here, or you may have to collect some more data. So you are going back in the process, right? So this line indicates you will be repeating the task, right? The yellow line which is shown here indicates that you may be repeating some of the task here, and you'll be coming with the model once again training and testing all this. So this procedure of doing the task of training and testing, maybe with the extraction of the feature or collection of the data, as such may be required many times in a standardization or to optimize your classifier finally for a better performance. So looking into all this, no, you may have to work out. So some may be by your experience, some may be by literature, you may be able to do it. Otherwise, it is by experimentally sometime. Right? So maybe initially you may think about doing some task, whether you want to collect which data, which is more appropriate, you have to plan. Anyway, the challenges will be there when you try to start with the collection of data also, right? That is what we were discussing in the last class. Every stage will have its own challenges. However, each stage, no, when you start with, it will take its own time. But when you compare now today, these particular two stages is a very time-consuming process comparatively for a new data. Because the model and other procedures can be quickly possible to complete these stages, 3 stages, because this is available as sometime app, as application or some kind of tool readily available, right? So this step, like these 3 steps could be easier today comparatively when you compare with the initial 2 steps, especially for the new data or new problem. So let us consider this and let us look into how we can go ahead with and what is the intention here is, say suppose you have some kind of patterns which are distributed like this, maybe randomly distributed sometime, right? So to visualize this randomly distributed, like how they are with respect to 2 feature maybe, so that they are belonging to, or you can make it 2 well organized 2 clusters or groups. With this intention, you may have to look for some kind of feature engineering, right? Or a kind of feature extraction process. This actually will help you to look for or to visualize kind of 2 classes which are like this, maybe in this form sometime. it is challenging. How to visualize this like this is a challenging, right? That the designer has to plan. So let us take a simple one of the example which is given. I think all of you can see some diagram here, right? So it is one of the standard example given in one of the textbook called Reinhardt, right? So it talks about how we can sort arriving fish through a conveyor belt. That means if you have a fish industry, how you can automate it. Automation of sorting of a kind of fish as an object on a conveyor belt. How these types of fishes can be optically sensed and how it can be categorized and how it can be packed maybe separately. These are the issues considered in the industry, such as packing industry for this, right? So all of you able to see a diagram, right?
Yes, sir.
Anyone, have you seen earlier this kind of fish actually somewhere? I don't know much about that, but still, you can see that here. There are two varieties we took in the example, right? Sorry. When you consider the species of, sorry, just one. When you consider the species here, we took two type of sea bass and salmon, right? Whereas this is longer, or it maybe the length is slightly longer in generally, right? That is one of the characteristic of this kind of species, right? But however, there are two type of classes now they consider in this particular fish. What is that? Sea bass and salmon. Now this is a class 1 and this is a class 1, maybe this is a another category, maybe we consider as class 2. See this, when it is seen under a optical sensor device such as camera, maybe it is able to take a photo of this and maybe able to understand its characteristic, maybe its length, then it may be able to categorize it. If you consider a single feature such as length, how you can do it? Or if you can consider multiple feature of that, then how you can do it? That is what they explore in this problem. The same design cycle aspect, how we can consider, that is explained with the help of this example. Instead of this, even you can take any of the examples such as ECG or any of other problem in healthcare also can be considered. But this is a typical example I will take here to explain various stages of. Any doubt with the problem statement? The problem statement is talking about arrival of fish on a conveyor belt. Okay. There are two varieties, two classes. Class 1 and class 2 are mixed up. So class 1 may be sea bass, the class 2 is salmon. Now having this in a conveyor belt, when it comes, the camera, such as CCTV camera or whatever, it can take a snapshot. And a computer which is having your classifier or recognition algorithm, sorry, inside which you may have your intelligent algorithm or ML algorithms. So this system having the algorithm now can take a decision whether the arriving fish or the captured photo here has what kind of fish, right? Based on the image or length of the fish. By computing the length of the fish, it may be able to length as a feature consider. It may estimate that and it may try to draw some histogram, or based on the histogram, it may be able to try to understand which is a group of fish of kind, right? you understand that there could be some classifier here. But how to design all this, it depends on the interest of the designer, what kind of classifier and how to design. But there could be a classifier which can help you to categorize. And if the decision is taken as it is Salmon or CBus, then a robotic arm could be actuated by the computer. That's what we are trying to do, some post processing where the arm will be going to capture that fish and it will put into a suitable bin, or it will be putting into another belt. Maybe it is another conveyor belt where it is just dropping. So from here it may be dropped here if it is of kind CBus. If it is of Salmon, it will just drop it here. The robotic arm will be actuated by a computer which is having suitable algorithm here. So that takes decision when the image is captured and take a movement. So that a decision will actuate the motor, and that motor help you to move the robotic arm in such a way that this arm will go left or right and suitably drop the fish into actual conveyor belt of interest. If the fish is identified here is as salmon, it will just drop it in this conveyor belt. If it is a CBus, then it will just drop it here. So it is finally trying to do some automation, right? Automation procedure, or it will try to automate the fish industry, where you will be having some intelligent system here and a robotic arm here, and the decision will be taken by this sorting of this arrival fishes on a conveyor belt will be taken care and will be put into some other belt, and later this will be going to some other process or will be packed, right? So this is the system arrangement when you're talking about a simple classification of a sorting of a fish. Is given by Duda and Hart, one of the famous example which most of the people will talk when you're talking about recognition system, right? So what is the system configuration you understood? So there could be some intelligent algorithm here which can really do that operation control of this arm, right? Depending on what algorithm you fit here and the accuracy, maybe 60% or 70% or 100%, that makes a group here, right, more appropriate. If your accuracy is 100%, you can expect all salmon here and CBus here. Else you may get some mixture here. Instead of 100% of salmon here, you may find one or two other fish also here. So why the accuracy is required here, you understood in a given problem. If don't have the quality of box what you get, later will be mixture of. So that customer may not be happy, right? That's why accuracy is very important in every problem. Because when you are saying that this is a box of this, that should have only that object. It cannot have the other object along with that. People are not happy in that case. Your automation get fails, right? Automation procedure may not be convincing others, so it may not capture the market finally. So in that case of problem, what they did initially is in their problem. So to capture the fish, anyway, they used a camera, you know that it is as a sensor, CCD camera. And anyway, some pre-processing may be required. Maybe initially they may have to capture the area of the fish, where even there will be sometime the multiple fish and other fish half may come. So they have to capture one at a time, or they have to capture all the object available in a complete object visible in the area, right? And they should take decision later, right? So some kind of image processing may be having some pre-processing also required, such as adjustment of intensity, all this segmentation of a region of interest. I think all of you know that what is segmentation. So this region, if you want to identify, this is a region of interest. Rest you have to eliminate, right? So this particular region of interest, if you get, you will get the actual fish region, right? So that maybe all this may be required in the pre-processing task. Once you finish that, yes, you may have to look for the feature extraction here. As a first step, the automation procedure in which they extracted length as a feature or intensity as a feature, intensity as a measure. And even they took other parameter like lightness, width, number and shape of fin, all this, position of the mouth, maybe eye related characteristics, all these they extracted as an individual feature. So then they thought that why can't we use length, because they found that length is a good separator. Then they just drawn a histogram for salmon and histogram for sea bass. I think in the last class we were talking about histogram. All of you can understand what is this, right? This diagram represents. So anyone? Can you unmute and talk? What is this X and Y explains here?
So the X here is the feature, which is the length in this case.
Correct.
And then the Y-axis is the frequency or the count.
Correct. So you're representing two classes here, two class problem. One is salmon and sea bass in the given problem. And you are understanding how it is distributed with respect to its training set or sample space. When you take a sample space or its salmon data set or its training data set, you find a number of samples here. You may have to extract feature nothing but its feature as taken here in this example as length. You measure its length. So the samples having length of 4, there are 2. That is grouped here. And length 5 is grouped here. There are 3 samples which are having length such as 5. So I have not given the training data set here. The training data set also can be shown, maybe having 50 or 100 set of data, where for each fish you may have to measure what is the length, right? So considering the group of salmon now, if you try to group them after measuring the length, having length of 4 centimeter or 4, unit 4, how many fishes are there? That are 2. Having length 5, how many are there? That is 3 here in this particular problem. So on, when you measure, having 10, there are 9. Okay, it may be mm. We don't know what is the measure exactly. It is not mentioned here. Length has to be mentioned with the unit. Maybe some mm here, right? So if you similarly do for the other case sea bass, even you find that length 6 or 7 unit, having that, how many number of frequently occurring sample in that data set, that is what counted here and tabulated. So with that set of detail, a histogram is plotted, right? So this is how it shows that they have the distribution, but somehow this is the tail region of the sea bass, and this is the tail region of salmon. That indicates that they are overlapping in nature. There is no well separation. There is a separation with some overlapping. That means that even there is some error, right? And when they try to get the performance, they are not happy, right? So they estimated some probability of error, that is 40% of error they found. Okay, it's a way of estimating the error. So they found it is 40%. So they took other features such as intensity, width, all this, lightness as a feature. So lightness, when they take, they found that slightly it is better. You can improve the histogram. That is, they just tried with single feature now. Design cycle approach, they started with single feature model, maybe histogram based models they tried, implemented. So they started first with the length, then took lightness and other measures. But however, in the case of lightness, it is seen improved from this. Here, if it is 40% error, here it is decreased. Error decreased. Performance improved. The region of overlapping is decreased here, right? The red region tail here, it is decreased compared to this. So when you choose appropriate feature with the single feature itself, you can improve the performance. That is what you can observe here, right? The performance of the model improved from this model to this model. That is a part of design cycle. But however, you can similarly try with other feature also, but you may not be able to get sometime 100%. Okay. So, but if you get, that is good enough to do even classification sometime. Yeah. In their problem, they could not get a good result more than maybe 70–80% sometime around that. Then what they did is they went for two feature based approach. Why the fish cannot be okay, the fish will be mapped or it is represented using a feature vector.
Sir?
Yeah.
When you say lightness, what do you mean exactly?
Yeah, it is some intensity measure.
Okay, okay.
Yeah.
Okay, sir.
Intensity based. See, even there are many parameters they will not take directly sometimes. We'll take as a ratio. We do, it's a maybe normalized value of intensity, something they take. It's not clearly mentioned, but some similar kind of measure they have taken. It's just to understand that how you can go with the multiple feature. Even they took width also another parameter. Okay, like there are many other. How much far the eye is from edge. All this some parameters like this they measure. But whether it can substantially can differentiate from the other category, that also they analyze with single feature. That they could not. When you could not solve with single feature, you can go for multiple feature. So you may have to use a combination of more than two or more features, such as feature vector. You can try to think about combining this, represent the pattern, and try to handle the situation. So in that case, we already discussed how to visualize the problem, right? It could be visualized as some space or region here in the feature space. Yeah, it is a feature space now, or this is a particular region we now consider as sea bass region, or this is salmon region, or you may call in some other domain as cluster. All the point which are looking similar, no? Or similar class, we call it as belonging to a region, no? Because they just plotted all this to get a visualization, all the sample of sea bass and salmon with respect to two features, maybe length and width or lightness versus width. When you do that, you find that they distributed such a way that most of the class members are together. Maybe one or two you can see still here, that this here, right? This is actually the class belong to other. But when you group it, considering that this is a region, then the machine will say that this also salmon, this also salmon. That leads to error. Okay. If you say that these three sample, which is red colored, when you consider based on decision rule, maybe a linearity based some rule, if you formulate here, the rule will help you to categorize saying that this region is for salmon. And it will say that this is the region of sea bass. But what happens? These black dots in this region will be now considered sea bass. They will be contributing to error. Yes. This is what happens here also. So there may be some outlier sample, or sometime it may not be possible to distinguish with even looking into two features to explain your patterns. Okay, it's because of that reason still some samples are here. Some samples are in the other class, right? But what you can observe is the performance, what they studied when they use histogram and scatter plot. See, by scatter plot, even they measured with respect to average scale of intensity and length, or with lightness and width. They tried with multiple combination of, and they found that it could be seen around 95% later stages after improving, right? With the two feature. They can go up to sometime 95 or 95.7% up to with this combination. But still there is an error, right? This still you can find error. So what they did is that they could be able to do it better by just making sure that using some neural network or some nonlinear design they tried, and they could able to get some 99.9% off. It's not even it's not 100%. Sometimes yes, you can. Some problem it may have a lot of confusions to the machine even, right? Anyway, what you need to understand here, one slide I have put, just say that when you are selecting a model, even we are trying to define a well defined boundary sometime. Maybe sometime may not be possible with the linear line. You may have to fit a non-linear line like this, or sometime maybe you may think that this may be far better, a non-linear of this kind, right? A complex nonlinear line also you can fit with the training set. But what happens? Anybody, can you guess? If I go with this?
Increase in computational cost.
Yeah, computation increases, true. Meantime, if you adapt that, still when you are going for testing, you may not get 100% result. Because testing samples are different, right? Random data you'll be using while testing. So it may introduce errors still. So generally we don't go for this much complex nonlinear functions. So instead of that, we try to go with some kind of balancing, like you just see and fix it somewhere, whether nonlinear, some simple function. Generally we do that, and we optimize with certain, we cannot standardize it. It is to the problem we may have to experimentally decide sometime. These are the challenges for a designer. Okay. So you cannot go for very complicated decision rule also sometime. So whether it is required or whether you want to fit it with a simple nonlinear function, that all these are left to the designer. Okay. But if you go for overfitting of this kind, a kind of fitting like this also may not give you good results. Sometimes because of overfitting or something, it may give even poor result than this. So this complicated decision boundary, even when you see for a testing sample, it may not be fruitful. It may give a poor result still. So what is the use of going for very complicated design here? That is a issue. Okay, some overfitting or things like that may happen. So you may have to rework on. Experimentally, you have to decide how to adjust the parameters later then. Yes. So sometimes we generally go with some generalized boundary, and we just keep it fixed for our requirement as a trade-off that is left to the designer finally. See, all these are decided by the designer finally to okay or not with the discussion with the customer. Which problem you are handling, where which class is more prioritized, more priority class. All this you may have to think, because for the both class, can you give 100% satisfaction when you are with the, without all these are challenges in the problem. Okay. Anyway, design cycle is going to address all these issues. So if you want to give more and more good quality of research, such as good 100% of classification without any error, then yes, obviously you may have to experimentally do it. Okay, it may not be possible with just single run. These are some of the design cycle aspects. And there is some more terminology we need to discuss now, like learning and training I was just talking about. So when I speak about learning, so what exactly happening here, the types of learning, right? We'll just summarize it quickly, and then we'll start with the models later. So looking into different types of learnings, You may be heard, some of you may be already studied that, maybe supervised, unsupervised, and reinforcement learnings. Can anyone give me brief out what is supervised learning? Can you unmute and tell anyone who studied about that? Can you quickly say what is supervised learning? Harshita?
Yes, sir. Supervised, supervised learning is basically the data set is trained under supervision, providing certain labels to it, such that the new data is classified under those labels.
Okay. So you'll have some supervisor or some kind of training data, right? That is what we generally understand. So it is a training procedure where some vectors or training vectors may be used or nothing but feature vectors. So we'll have some target also along with that. That is called supervisor. A target vector, what is required at the output or desired output, right? So we'll be using two set of data here for training. So what is that? One is actual input. That is nothing but the feature vector, what you extract for a given pattern. Along with that, the target or desired output. So set of these will be used for training. That is a specialty of supervised, where you'll be saying that for this input, okay, this is what required, expected, desired output. For this is what required, you say, and you try to train this. For getting this, some manipulation should be done here, right? So generally, an analogy example can be said to be like this. It is an analogy example. Say, suppose you will be going for supervised. That could be a supervisor. Supervisor, somebody who can guide during learning, right? When you are learning something, some teacher or some kind of supervisor arrangement in the system can help you to learn quickly. That is what the model, one of the model. But the other model is just unsupervised. You can even get a lot of information and understanding from the available material by going through yourself, right? It's a kind of utilizing the resources by the candidate itself. So that is an analogy example for unsupervised. There will not be any trainer. You will not find this trainer here, right? So this is a system where supervisor, there will be a trainer along with the training procedure. Whereas unsupervised will not have a target vector, we call in a technical term, or desired vector may not be there. What you need to get as a output, that is not defined with the help of desired output, right? So the concept of doing this training will be slightly different. So in case of supervised, it is done with a pair of vectors like input vector and, so you'll be using here a pair input vector is a feature vector. Along with that feature vector, you will be using a target vector, desired vector, or desired label that is used as a target vector here. For that input, what is desired as a label that is kept as a vector form, generally in the detail system. So for given input, say you are expecting as a normal. For a given input, another input, you may be expecting it as a abnormal. If it is known and labeled, it will have a labeled target, right? So that is what we are trying to do it. During training, we'll be making use of two vectors here. So using that, you'll be trying to train the model. For this input, you are expected to give this result. That is what you are going to train there. Say if I say today some concept, this what this, then you need to understand that what is the data collection means collecting the data through this. If I say you should be able to understand that data collection is like this, right? So it's some kind of a trainer will help you to do this procedure overall. Whereas here there is no trainer, but still you will be able to do it. How? It is with the basic similarity based approach. We try to group the information here. That we will discuss later. So in generally when you take a class of kind of having some object, I think class name is already defined here. The data set, what you look for in case of supervised may look like this. It is nothing but a label data set. So when you are going with the supervised approach, we'll be making use of label data set. I will be knowing that what is the data I'm going to use. All these are labeled. Its target is known. So all these are labeled data. Or the other class also, I know what is the object is. What is it's known. It's known data, right? Right. The target, it is called a label data set. Generally, label data set for each class is used here. Whereas in case of unsupervised, you may not have a label data set. The data set may be something like this. So maybe you will be going to directly try to use this for training purpose. Maybe it will have a mixture of both. Object, you can see it is a mixture of. But however, you want to divide this into 2 group or 3 group, that will be known to you. So then you will be trying to do some kind of approach for doing that. Maybe similar thing you put together. Based on some feature, you may have to group them. That is what you are trying to do with the unsupervised approach. But in case of supervised, it is already known that this set is having a label. Or this group is having a data of such kind. It's well known. Okay, these are the major differences you find when you are talking about data sets of both. And overall concept involves when I was talking initially the term supervised, I mentioned that the input is nothing but a feature vector, maybe having feature more than 2 or more features, right? So you may be trying to train, say, one of the models, such as neural network models, say, that's what written here. Then how it can look like the arrangement? You will be providing input. You'll be trying to derive some output. Whereas one more input you'll be providing, that you call desired output. So these are the 2 things, pair of vector you'll be using to get this. So this and this is the pair of input used. So any doubt here? Let's see, here there is one input, which is the feature vector. What is feature vector? All of you understand. It's nothing but a pattern what you indirectly see in terms of few features, right? But what you are going to label it, or its target name or label, actually defined here as another vector, desired output. You'll be feeding both to this particular arrangement or the network. It is to train it. During training phase of your learning procedure, or during training, what we see is here, you'll be applying this, you'll be applying this. then what happens here when you apply this is an output is generated, and that also will be seen past one of the block here, which generates an error with respect to this too. Error is calculated. This error is used for doing some changes in the network settings, especially we call weight in the network. So some parameter of the network is updated here. So what you observe here is when you apply input, it generates an output, but in meantime you're providing a desired output. So what happens when you take it this same output here, you can estimate an error. That error will help you to update a parameter here. Thus, this is a learning procedure where understand that there are two parameters, two set of pair of data is used for training. So till what time you have to train? The training will be a sometimes cyclic approach here, or it will be done till this error becomes small, or this actual output becomes desired output, right? You stop training. The training procedure will be stopped. So once you get the actual output as same as desired output, then you can say that the system has learned about your inputs. So that is a training procedure, and once you finish your training, then if you give a random sample here, say of P1 or P2, your patterns as a vector, then you can expect it is classified with more or less as you desire. This is what happening in the supervised models generally. And in case unsupervised models where I said there is no target, right? This is the target or desired output. This is not here. Target is not there. Target is there. You can find only one input is used here. Input is fed, and the output is used for modifying the parameter of network using some control. So this also help you to try to understand the pattern, help you to do the classification, so on, various error detection, so on work. But the problem is, yeah, it's a different type of model. Yeah, any question here? You got the difference between these two, basic difference? Anyone has any question? Here there is a supervisor. Here there is no supervisor in generally, or in technical term you can say that there is a target here in supervised learning. There is no target or labeled data here. Okay, there is no labeled data. You may have unlabeled data here, which is arriving based on similarity or based on some rules adapted here in the model. You'll be trying to group them. That is said to be unsupervised. The term came because there is no supervisor or no target. That's the meaning from behind that. Even sometimes we use reinforcement learning methods, such as it's an alternate method. There also there will be input and there will be target, but the target is called here reinforcement learning parameter. The output, actual output, and this reinforcement signal will generate error signal here. A minor change from supervised, that's what you can observe here. That is a similar category of supervised, but there is a difference. In this case, the supervisor may not give clear indication for learning. He may just say that you are right, you are wrong, or you are just doing in the right path. An instruction, partial instruction given for correction of the output will help you to update your parameter here. So it is also another model used for learning. These are the three models generally seen, typed in generally. In detail, when you go, even there will be various rules adopted or various methods adopted, parametric or non-parametric, or sometime you find different models based on sometime very simple rule, sometime using certain mathematical approaches, sometimes using some network of such kind as neural network, right? Or deep learning, we call the multiple names with multiple models, we label it. So, but in the design cycle, you can choose a simple one always initially, or if not possible, you can go to higher level sometime or other models. Or you initially itself, you can go to one of the guess and choose one of the model and just implement. That is what it happens when you are implementing some application. Let us take one or two example here about this model. How actually a pattern recognition helps here. Considering a simple recognition system, I think all of you understand that when there are some characters, what are given here? Varad, are you online?
Yes, sir.
Yeah, which are the letters you can see? I have given a recognition of letters. The problem as recognition of letters.
Yes, sir.
Okay. So which are the letters you can see here in this given problem?
Sir, LPOEQ.
Okay, suppose you want to categorize these. Okay. So what can be a method? Generally, you can adapt. Randomly, you can think any one of the model you can choose in generally, right? So taken an example to talk about how you can go with a simple decision tree approach or some simple tree structured classifier, how you can design here. So suppose to classify a kind of letter from other letter, L to P or P from O, right?
Yes, sir.
So given problem having multiple letters, you can see how you can differentiate them and how you can label it, right, of a particular class.
So using the features.
Yes, once again, you may have to, yeah, the first intention is to choose a feature. Yeah. What feature you want to extract, that is left to the designer. If you are the designer, what is the one you extract? That is what question mark. But if you plan for selecting this approach, a simple feature also you can extract. Feature taken in the given problem are this.
Vertical, horizontal, oblique and curved lines.
Yes, lines are considered as. So it is something like capital letters are considered here, right?
Yes, sir.
We have not considered a L of this kind,
Yes,
right?
sir. Yes, sir.
If you consider this kind, it will give another problem. So you have
So,
to
sir, using these
put,
features.
yes, features should be more complicated one or more higher level of features you may have to use. Okay, but given
Okay.
a simple problem now, you understand here with this feature how you can go ahead and classify. What we did is you just extract the feature. For example, there is L. How many vertical line? L is having vertical straight lines. Is it there? Yes, there is one. Mark it. Okay. So is there any horizontal straight lines? Yes. Mark it. Is there any oblique in L? No, right? There is no oblique lines here, so 0. Curved lines, if any, no, 0. So this vector now, L is represented using 4 numbered vector now. These are the feature details. So L is described with 1, 1, 0, 0 as a column vector. Now L is explained with this. What is that? It is nothing but a feature vector consisting 4 features. Correct. The feature values are 1, 1, 0, 0. So this represents L now. You're getting my point. This vector is representing L. Now if you see the second pattern, any letter here P. So similarly, if you just tabulate it with this feature, say for example, vertical, there is 1, yes, one portion is vertical. Say horizontal, no horizontal lines. Oblique, there is no oblique, but there is a curved line, yes. With this, if you develop a vector, it represents P now. So on other letters, you can try to. For example, in case of E, you have 3 horizontal lines. So this is how now a kind of feature vector is developed here. So this has to be planned. Which feature you are focusing in a problem has to be planned by designer. It's a designer means if you are the designer for realizing the solution, then you may have to plan for the given problem, which is maybe height of subject or weight of the subject. You may have to decide whether a straight line here, horizontal straight line or vertical straight line, oblique straight line, right? Curved line. This is just a thought made us to go with representing the pattern. See, this thought helped us to represent this in digital, right, as a vector. 1, 1, 0, 0. So once you design this vector, yes, you can use this for developing a tree also. Oh, if I go on take a decision nodes here, right, and a rule if I keep here, for example, how many vertical lines you find here, based on that you try to make a rule here, if else rule, right? If vertical line is greater than 0, if it is true, yes means true, you take a branch. If there is vertical line, you come this path. If there is no vertical, then you take this path. So branching node, it is a branching node concept, right? If else concept. So then if you take this node as a decision node, you will find branching based on the decision. So corresponding decision will help you to take branching to multiple branch and finally to a end of the tree, right? It is nothing but your expected pattern. So when you do that, you can represent your character. That is how you are designing now with the branching, routing and branching concept. So you have a start of the branch, maybe it's end of the branch, end of the tree, start of the tree here, end of the tree here, right? It's taking branching in every node. There you may have to put some rule, right? These rules are designed by the designer based on circumstance. Maybe here it is designed based on lines, vertical lines here, curved lines here, horizontal lines here. So sequence of rules are adopted such a way that then you are able to explain this whole patterns of given type in the tree form, right? You may be able to design a tree so that it will help you to do the classification. So adopting these rules systematically, I think understood what we are trying to do here is first you adopt vertical for that. Is there a vertical line or not? Yes, if there is a vertical line, then all these characters will come under that group, you understand. LPE. Yes. Under no group, there is other two character will come. However, when you go to branching left, yeah, once again, the next rule will try to separate among LPE, which are the character which comes to the left or right. Is there is a curve here, L does not have, P has, E does not have. So L and E is made a group here because of the branching here. Because of the branching here, curve greater than makes a grouping for one category, whereas L and E will come here to right side, right? P will come towards this side, grouping. The rule will separate the object here, or category of object which comes similar. See, based on those set of feature, now go on, you're branching it and finally landing with the actual pattern here. So multiple features should be extracted so that you should be able to go across a tree, right? It is a structured way of achieving labeling a particular pattern, right? Using multiple decision rule here at a different branching point or node. You can call it as a node. At each node, you'll have a rule.
So,
Yeah.
For the horizontal straight lines, both L and E have horizontal lines. So should it be h greater than 1?
Here there is some error. Yeah, there is some error. You have to correct it. H greater than 0, right? Horizontal line here. Whenever you curve is 0, okay. Horizontal line greater than horizontal line greater than 0. Greater than 1 should be, no?
1. Yes, sir.
Yeah. There is an error here. Please correct it. Okay. It should be 1. Because L also has a horizontal line, right? Yeah. So if it is greater than 1, then it suits. So it's a simple rule-based approach you are trying to follow here in a decision tree based kind of tree structure, right? Adapted for doing the categorization. Now, it's one of the simplest rule, but may not be suitable for all the problems. That designer has to choose which problem, which model will suit from the literature or his understanding with the models, right? For example, some other people might follow this kind of approach. If there is a scene, there are multiple objects. It's just one-to-one match you can do sometimes, right? It is very simple approach called template matching, right? But it's not a very good approach, but still people can do it. Matching and whether this three-sided object is there or not. Is it a three-sided object? Is it a three-sided object? You can just cross-check. If it is a three-sided object, you may call it as some object. Right? This given template is a triangle, right? Matching with that. So it's something like there are different models now existing. Only thing the designer has to choose sometime. So here it is an example just to say that this simple template matching can be used for some kind of problem such as detection of this portion of the brain. Anybody seen MRI image and have gone through this? Anywhere you heard about corpus callosum, right?
Yes, sir. It connects the left and right hemispheres of the brain.
Yes, so it's one of the important region which has this is a very important region of our brain actually for balancing, right? So many things. Like if there are morphological problems or a lot of problems with the structure of this will create a lot of other problems with the brain related problems. Alzheimer, or whatever it is, so many. So this is very important area. If you want to just segment this from MRI, right? Even this region could be segmented with the template approach. One of the paper which incorporated that technique is highlighted here. Okay. So how you can get this template, or how you can get this region of interest. Right. This is the actually MRI. See. Doing step-by-step operation with respect to this, a matching operation. You can even extract this region. So one of the paper, how they extracted, I just put here. You don't worry about this for the examination point right now. Okay, just as an example I have put. Just to get an idea that people are able to incorporate any technique in different domains such as healthcare. Just to indicate that I have put this, but don't worry about this in detail right now. Okay. So even there are other techniques like neural network, right, which uses some, we'll discuss about later. Yeah, some statistical method, right? It tries to describe the class in terms of some probability density function, right? Even I gave an example where even we extracted structures like even horizontal line, all this. Even structural entities can be extracted. So there are multiple approaches. A feature you can extract, even feature can be visualized in different way, and you can go with the different methods. So finally, the designer has to choose one of the method, and he has to look for the optimization and things like that. And experimentally, he has to decide which is the better method. So these are challenges for any recognition system. So the block diagram, when I talk, earlier I gave a simple block diagram of recognition system. This is something like a slightly elaborated diagram compared to earlier diagram, which is the training area which I have emphasized. You can see the lower half is for training, upper half for the recognition. It is the same diagram shown with the two sets. You can see easily. The lower half is trying to focus on when I consolidate the overall thing what we discussed about a pattern and some visualization, some feature related aspects, and some learning aspects. Now in a system, if you try to consolidate all this information, how it looks like a kind of arrangement, right? So you understand that the lower half try to indicate a training phase of the system. You feed your patterns, which may be with the labels, right? Where it may be required to have some pre-processing initially. Then you may have to extract features, as we discussed earlier. However, then some model has to be trained. This is called training phase. That is why we have shown a dotted line just to show this. This is first phase of our task, training mode. So once you finish this, you can apply a pattern here. This is called test pattern. The system arrangement have a common block maybe, but it is in the block diagram shown in a different way, that's all. Okay, the pre-processing may be the same hardware sometime. Okay, don't confuse yourself. So this second mode of operation we have shown highlighted here with the blocks. That is recognition part of that. So where you do once again the pre-processing of the pattern, then extraction, then maybe you are doing classification, right? So you'll be using the rule already set, or based on certain threshold, you'll be labeling the data now. The random data fed here, random or test data fed here will be labeled here. So there are two modes here. One is recognition system, pattern recognition system will have two modes. So first mode is this, training mode. And the second is recognition mode or testing mode here, right? So is it clear? People may write slightly different block diagram, maybe it is single flow also fine, okay? Just to show that it is, some authors will write like this, that's why I just wrote like this. Anyway, this don't worry about this with the structural, how you can do it, it's the same block diagram. Because when it comes to different pattern, even it may suit better. Just to say that I have put here, don't worry about this right now. Anyway, this also we'll discuss later. A kind of another model, which will have, I think all of you know the basics of this, I believe. Yeah. So what you guess, anybody, can you guess what we are going to use here? Can anybody can talk about that? What is this model basically consists of? Anyone, can you unmute and talk? 5 minutes, we'll discuss on that. Hello.
So an artificial neural network uses multiple layers to take in the input and then generate the output. Since like if it's supervised, it gives the target vector predictions. So it uses a set of interconnected layers starting with the input layer and going through multiple other hidden layers until it finally reaches the output layer. So neural networks are classified based on how these layers are connected with each other.
Correct. There will be maybe multiple layers maybe there, or there will be some nodes, nodal representation, right? Each node may be some computing device there, right? Computing area. Okay, like you may be knowing biological neuron, right? Like each biological neuron, how it process, right? I think all of you see in biological neuron detail will have some kind of dendrite, and later it will have some processing area, then will be axon, right? And once again there is some junction, from that there is one more dendrite connection for other neuron, right? So there will be multiple connected cells like this, right? So this, if you try to mimic, the idea is here to mimic a kind of neuron, right? Biological neuron. All of you aware of that? Biological neuron is a processing neuron where it processes some biological signal, right? But when you talk about biological network, it will have multiple connection of neurons. How many? If you guess, it is too many, right? In the brain, you will find many number of neurons. And even there are, even at a junction, you even find multiple number of interconnections. So many number of interconnections at each junction. It's a huge, massively interconnected network. As a biological network you find. But when you mimic this kind of network now our task is to mimic this. Yeah, as she has mentioned, it is a large network where there are multiple nodes, and you are now mimicking this. What is mimicking means you will be trying to model it, right? You'll be trying to represent biological network, how it functions, how it is connecting each other and how it is performing, beautifully taking multiple parameters, right? So because if you see biological sensors, how many sensors are there? Human has, anyone can say how many sensors we have generally? As a human body, we have several sensors, right? Sensing organs. So we have a parallel processing system in our, right? Brain is a parallel processor, right? You agree with that? So it's a massively arranged parallel processing network. Similarly, here, when you talk about neural network, artificial domain, even that kind of networking may be required with the computing devices. That if you can really implement, it will mimic like brain chip, all this. Whenever you talk classifiers, all this, it will be. So massively connected neurons, it is very difficult to implement in a very large number. But now it is demonstrated that deep learning is trying to do that little bit. Deep learning platform, trying to do that. But still it is not reaching the level of brain capacities. Still we have not reached it. People are near to that, yes. They are trying to do similar kind of work. Not all at a time, but some at a time. They are able to do it. It is because of high-end computation devices we have today, we are substantially able to mimic some of the capability of biological networks. So with the artificial neural networks now, we are also trying to create a similar kind of neuron, right? Artificial neuron, which can accept some input and which can process and which can deliver some output. So looking into all these characteristics of a biological neuron, you try to mimic it. So you get some signals. Here, signals, right? Here, instead of that, you get a features. Try to acquire the features. Those features you will be suitably weight with suitable. So there is a strength. The strength of the signal arriving each dendrite may be different, right? Similarly, the input which is arriving to a node for processing here also may be weighted input. There will be a parameter called weight here. Okay. So when it comes here, it is x1, w1 will reach here processing node. x1, w1, right? So when all other node receives other signal also here, maybe x2, w2, maybe x3, w3, so on. Like how dendrite help you to receive multiple signal here, maybe a biological neuron. The artificial neuron also does similar task. It tries to collect some features of a pattern. And this is a processing node. A node is helping you to do as a processing node. Here you have some region of cell. What is that called in biological neuron? What is the cell region? It's a dendrite, it's pictorially. What is this region called? Anyone?
The cell body.
Yeah, cell body. Yeah, correct. So this cell body, or this is the processing region of here, natural biological cell. So here we call it just as a node, a processing node, right? So it is nothing but we are mimicking it. But all functionalities are not it, but still some functionalities are adapted from this, or we are mimicked and trying to do similar functionalities we are trying to provide to this model. This is, I'm talking about single neuron. This is a single neuron. But a neural network will have similar multiple neurons. You may be seeing some diagrams of this kind, right? A layer will have multiple nodes, those kind of processing nodes. Here we'll have multiple nodes. Here we'll have multiple nodes. So suitably, when you train this model, it can also learn, right? And it can help you to do the recognition. That is what we talk here, right? A neural network approach. So it may use some kind of threshold. For example, theta is a threshold here. So it will be trying to use of some evaluation rule or some kind of rule here. So that help you to decide what is its output. Say output is y here. You know, in a normal biological neuron, when the input is sufficiently high, the biological neuron is said to be triggered, right? You call it is triggered, right? Similarly, you can find here output is getting high whenever the input is sufficiently high or above some threshold. That is why when Wi into Xi is nothing but the input, their sum is sufficiently high than threshold, or the difference is such a way that a function is defined for getting your output high. Okay, so it's a binary neuron which is shown. Can generate output high or low. When it is triggered, its output will be high. When it is not triggered, you may find output as 0. Like biological neuron also, when it is triggered, it will have a response, right? Similarly here, its output also, you can make it binary high or binary low. So whenever the inputs are changing, that input after processing here decides whether the output need to be high or low. So when you map it suitably, these input with 1 and 0, it helps you to do classification. For certain inputs, if you define that its target is 1, it is trying to represent certain group. So thereby later it could be even used for some categorization or recognition problem. But try to understand that it is a simple model of neuron here, which could be trained, which can be generally said to be trained. Okay, that network of this kind of neuron will be called neural network. So obviously that also can be trained. But a mapping of having a kind of network, very large network, and understanding individual neuron that time will be very complex. And relation between them will be really, it is very complex procedure. Even in the artificial domain also understanding it is very complex procedure. But however, there are a lot of models which have come up today, understanding so many parameters of natural brain, right? Natural activities happening in the brain. So they mimic various functionality of the brain and they have developed various models. You know, memory networks and so many types. You know, our brain can retrieve the content with certain style. If you see some content today and after 5 years, if you see that similar content or face of person, correct? So you know that who are your teachers now. After your masters and after 5 years of service, when we meet each other, say, you may be able to recognize us by looking into our face, even though there is a small changes in our facial expression now, where overall face may be changed, but still you are able to see and recognize. It's because of your capability, your brain capability, where it can try to find out some hidden characteristic from that face, and you are able to retrieve, right? Some content-based retrieval procedure is adopted then. So people are mimicking various concepts of this brain, maybe functionalities of brain in the form of computing area, like computing network here. That really helps us to do many tasks, not only classification, even error detection, all this segmentation. So many work you can do from this. Lot different types of computation, different computations or different parallel processing activities. Parallel activities we can do it. So you know how brain does many parallel activity like that, even you can do with this. Yeah, that's all from the basic terminologies. I'll be starting with the next Bayesian model for recognition. So to start with, there is some probability introduction that you have to go through it. I will just pass it with my slide. So you can read and come back. We'll have 5-minute discussion. Quickly, I will run through that. When you are coming to the next class, you can go through that and come. So that we will define the theorem and let us try to express some classes, how to visualize the various classes with the models, like probability density models we'll discuss. Our next task is to find out here how this theory will be useful for visualizing the class. Okay. Maybe to understand this probability and probability theory, how it can be helpful for prediction, how it is able to useful for visualizing a class. So we were talking about how you can visualize given set of class members in the form of histogram in the earlier class. Now, how probability models are describing a class and how it can be useful in our other understanding with the classifier, right? That we need to discuss here. So your basic understanding, I'll quickly run through 5 minutes and then I'll pass this slide. You can go through and come back in the next class, okay? But then we'll go for representing the class. So all of you aware of these terms, just as an outline of, be aware of all these details because these are a very important basic knowledge of yours, okay? So why I have put this is, easily you can understand that when there is a gift which is coming to you, right? What is inside is always a question mark, right? That we call some uncertainty, right? So whenever there is an uncertainty, we will try to use the term called probability even, right? This comes associatively with this problem, right? Anyway, probability is a way of measuring, you know, that chance of some happenings. All of you aware of that. It's a way of expressing knowledge, even, right? Or it will try to help you to quantify some occurrence. So the probability to measure a chance or likelihood of an event will help us to describe some event even, right? How exactly may be studied in some problem such as coin problem, having fair coin, right? Or unfair coin, right? So when you toss a coin, all of you know that right? In this experiment, what happens? So there could be some understanding that you get one of the phase, maybe head or tail, or like head or tail, you will get it, right? So one of the phase is expected here. Outcome could be one of the phase. So in a fair coin, when you are tossing, you are generally expecting it as head or tail, right? So what happens when you toss it? That can give a outcome, right? But when you do all this kind of experiment, there is a term comes which we call it as a prior knowledge. What is that prior knowledge? Anyone? Anyone prior knowledge of tossing the coin? What is the outcome you can get in when you're tossing coin? I think all of you are aware of very well, right? It is a simple experiment. All of you, well, it is a well-known standard experiment, right?
Yes.
Yeah. So now, in this case, when you're, it is just to understand the example is given. Don't think that the problem is asked in examination. It is just to understand here. When you are tossing, if the number of outcomes are getting ahead, right? The number of outcome expected totally are this head or tail. So based on that, you express now probability for getting ahead. Probability of getting ahead could be 1/2, because you know that is a standard relation, right? Number of outcomes in the event, like for a particular getting ahead, maybe to that of total possible outcome. That is what I defined. So when you are trying to define this for two coins, it may be slightly different, right? Multiple coin also it is possible. So event or events, it is possible. So however, there is a term also defined, sometimes called as an experiment. For example, rolling a fair six-sided die, like it's an example for experiment, or maybe randomly choosing 10 transistors from the 1000 new transistors, or testing a sample for COVID-19, right? All these are some experiments. This event also you studied. I'm not going to define this. Just go through it. Okay. I think all of you are aware of this rule, right? This is a very important rule. So we call it is a multiplication rule, right? I think all of you are aware of this. Now, anyone, can you unmute and read this? Hello, Aishwarya, you're able to see my slide? Rishiraj? Rishiraj?
Yes, sir.
Yeah, you can see my slide?
Yes, sir.
Yeah, in this multiplication rule, you can see, can you read this multiplication rule? Say when there are two events, A and B, are dependent, the probability of both occurring, P and B, how it is expressed? Can you read that? P of A, and what is the second term? P of P given A, right? So you may be seeing that this kind of representation of the probability where P of A is said to be prior probability, whereas this probability is said to be condition probability, right? So I think all of you studied this, two terms, right? All of you know this, no? Two probabilities. One is condition probabilities, one prior probability. Say P of A is the prior probability. P of B given A is, or P of A given B is a condition probability. Why we refer condition probability? Where we know that one of them is given, right? You are expressing the other one, other event. With respect to other event, you are trying to define the probability, right? So these terms are very much familiar to all of you. That's what I believe, right? So there are two probabilities, well-known probabilities you have in your list. That is, one is prior probability, one is condition probability, right? So when A and B are two events, the probability of A may be defined, right? Sometime as the probability of A, right? This is referred as prior probability. Okay, probability of occurrence of A, you are defining as P of A. But when you are trying to define a kind of probability, condition probability, such as the probability of some event A given the occurrence of some other event, are referred as condition probability, right? See, this condition probability is slightly a different probability where you will be trying to define probability of A given B, right? Or knowing that B has occurred, right? Something like. Then the condition probability may be defined. But how you relate them? This is related from the multiplication rule. That is why I said this is an important rule. You should remember it. Multiplication. Yeah. Yeah. Tell me. Yeah.
Yeah. So it's past time.
Yeah. I'm stopping. I'm stopping it. So I'm stopping it. Yeah. So till here, I think just a basic reading. You can just be aware of that. It is not for the question. And here onwards, we will try to relate to the actual topics. Okay. Next class, you will try to visualize based on the probability. Try to visualize some classes. How various discrete or other class visualization could be possible. Continuous probability density function could be utilized for visualizing the class and or some other recognition problem. Okay, let us take up that. So this is a basic reading. You be aware of that. It is not directly going to fit into the examination. It as a basic knowledge you should have that. Okay, that is why I just gave here. Just keep as a kept as a reading material here. Okay.